Every day, United States soldiers in battlefields abroad sustain traumatic injuries that require immediate surgical intervention. Imagine, you're a surgeon on one of the Air Force Special Operations surgical teams there to provide these life-saving procedures. You receive a constant flow of up to 15 patients a day, and you need to operate back-to-back for 16 hours. However, surgical tool sets are limited. You only have 5 full sets, and your sterilizer takes 2 whole hours to clean one set, meaning you'll need to make the decision between wiping off the blood of one patient off of your scalpel and then making the first incision on another patient, or delaying surgery, putting the patient at risk of bleeding to death as you wait 120 minutes for the sterilizer to clean your tools. We are Team PASS.
And we aim to innovate upon current steam sterilizers
to design a durable, quick, and effective portable advanced steam sterilizer.
Prevent surgical site infections
in patients at forward operating bases.
To address these problems, we interviewed 20 users from the United States Air Force Special Operations Surgical Team and experts in the field of steam sterilization. Our team learned that current sterilizers are effective and easy to use, but lack in durability, portability, and environmental safety, and most importantly, speed. We aim to improve on all of these points within the $15 billion global market of sterilizers that affect over 1.4 million active U.S. military personnel. Finally, we introduce to you PASS, the Portable Advanced Steam Sterilizer.
PASS is made up of 3 main novel components. First is a plate heat exchanger that is capable of quickly producing steam that is released into a sterilization chamber which holds the tools. The second is a steam jacket tank, a durable container that can hold steam at high temperature and pressure. This component essentially eliminates the need to wait for the entire device to preheat, as there will always be a storage of readily available steam, and sterilization cycles can now run back to back.
The third component comes into play after the tools are already sterilized. The air inside the sterilization chamber is hot, so we propose use of helium gas to purge the steam and absorb the heat. This will rapidly cool and dry the tools, allowing surgeons to get their hands on them faster than ambient air cooling.
PASS is durable. Designed with our end users in mind, we built PASS in the 1646 Pelican case, with each component being screwed into or held into place by fiberglass supports and insulation. For our benchtop testing, we dropped the device from waist level and found that all parts remained secure and operational.
PASS is portable. The case features low friction wheels and an easy to operate handle that allows the entire device to be pushed instead of carried. In an environment with uneven grounding, PASS has 2 easy to use handles, meaning it can be carried by 1 or 2 military U.S. personnel.
PASS is environmentally safe. It does not use any harsh chemicals or require any dangerous materials to be moved across country lines, unlike predicate devices.
To protect our users, we've also completed intensive benchtop testing to eliminate the possibility of leakages. We've implemented exhaust valves and control points after each phase of sterilization, where the device can be manually stopped. Additionally, we have internal pressure gauges and temperature probes that provide us with feedback on the device's operation status, which we can control by adjusting temperature settings and valves to maintain appropriate pressure.
PASS sterilizes a standard surgical tool set in under 45 minutes. The device is able to provide a constant stream of high heat and pressure, allowing for tool sets to be loaded into the chamber back to back. Surgical teams will no longer need to worry about not having tools available, as many sets can be prepared nearly simultaneously. In our benchtop trials, we were able to verify the sterility of these tools using sterility pouches that successfully changed colors from light blue to black after just 40 minutes in the sterilization chamber. The helium purging process then takes only 5 minutes to cool and dry the tools.
For our next steps, Team PASS first aims to make the system at a lighter weight. For its intended use in the military, the full system needs to not exceed 80 pounds, which is the average weight of the predicate devices. We also want to verify the sterility of surgical tools at a microbacterial level via cell culture. Lastly, we intend to file patents and any information needed for IRB and FDA approval. Thank you, and help save lives with us.